Welcome to DeVos Education. I'm Mrs. DeVos and today we're going to talk about NPK and eutrophication. Nitrogen is essential to the production of plant and animal tissues. It is used primarily by plants and animals to synthesize proteins. Nitrogen is a vital component of chlorophyll, the compound used in photosynthesis. It's also the major component of amino acids, the building blocks of all our proteins. It forms part of the energy transfer compound known as ATP or adenosine triphosphate, and it's also part of our nucleic acids such as DNA and RNA. So without nitrogen there would be no life as we know it. Some specific growth factors that have been associated with phosphorus include stimulated root development, increased stalk and stem strength, improved flower formation and seed production. It also gives more uniform crops and earlier crop maturity. It can actually increase the nitrogen fixing capacity of legumes. There's a general improvement on crop quality, increased resistance to plant diseases, and it supports the development throughout the entire life cycle. Potassium is an essential nutrient for plant growth. It's classified as a macronutrient because plants take up large quantities of potassium during their life cycle. In photosynthesis, potassium regulates the opening and closing of stomata and therefore regulates carbon dioxide uptake. Potassium triggers the activation of enzymes and is essential for the production of ATP. Potassium also plays a major role in the regulation of water in plants. Although used interchangeably, the terms legumes, pulses, and beans have very distinct meanings. A legume refers to a plant from the Fabaceae family, including its leaves, stems, and pods. A pulse is the edible seed from the legume plant. Pulses includes beans, lentils, and peas. The root nodules of leguminous plants are caused by nitrogen-fixing bacteria belonging to the genus Rhizobium. Atmospheric nitrogen is a major source of nitrogen in soils. In the atmosphere, it exists in the inert N2 form, and it must first be converted before it becomes useful in the soil. When the quantity of the nitrogen then fixed by the rhizobia exceeds what they need, this is then shared to the plant. This is why well-nodulated legumes don't often respond very well to the addition of nitrogen fertilizer because they're already receiving enough from the bacteria. Nitrification is the biological oxidation of ammonia to nitrite, followed by the oxidation of the nitrite to nitrate. Denitrification is the microbial process of reducing nitrate and nitrite to gaseous forms of nitrogen, primarily the nitrous oxide or N2O and nitrogen N2. A large range of microorganisms can denitrify. Denitrification is a response to change in the oxygen concentration of the immediate environment. Phosphorus occurs in dissolved organic and inorganic forms or attached to sediment particles. Phosphates, the inorganic form, are preferred for plant growth, but other forms can be used when phosphates are unavailable. Leaching is the process of a solute becoming detached or extracted from its carrier substance by way of a solvent. Besides human urine, there are many other naturally occurring sources of phosphorus that can be used in farming or gardening. This includes bat guano, bone meal, crab and shrimp waste, burned cucumber skins, hair and mushroom compost. Phosphorus is a vital nutrient for converting sunlight into usable energy and essential to cellular growth and reproduction. It is one of the 20 most abundant elements in the solar system and the 11th most abundant in the Earth's crust. Not only do phosphorus hold DNA and RNA together as part of their backbones, the sugar phosphate backbones, but it's also a vital component of ATP, the universal energy carrier. ATP forms during photosynthesis and is released during the process of cellular respiration. Just like people, crops also need special minerals to keep them healthy and to have them yield their maximum potential. This is where fertilizers plays a very important role. A fertilizer is any material of natural or synthetic origin that is applied to soil or to plant tissues to supply one or more plant nutrients essential to the growth of the plants. Artificial or synthetic fertilizers are man-made combinations of chemicals and inorganic substances. They typically combine nitrogen, phosphorus, potassium, calcium, magnesium, and a few other elements in different ratios. Artificial fertilizers, unlike their organic counterparts, immediately supply essential nutrients to soil. Examples of naturally occurring organic fertilizers include manure, slurry, worm castings, peat, seaweed, and guano. Green manure crops are also grown to add nutrients to the soil. Naturally occurring minerals such as mine rock phosphate, sulfate, or potash and limestone are also considered organic fertilizers. When nutrients and other pollutants associated with animal manures and commercial fertilizers are not managed properly, they can affect plant and animal life negatively. Phosphorus and nitrogen are the primary nutrients that in excessive amounts pollute our lakes, streams, and wetlands. The main source of nitrogen pollutants is runoff from agricultural land, whereas most phosphorus pollution comes from households and industries, including phosphorus-based detergents. Nitrate, a compound containing nitrogen, can exist in the atmosphere or as a dissolved gas in water, and at elevated levels can have harmful effects on humans and animals. Excess nitrogen in the atmosphere can produce pollutants such as ammonia and ozone, which can impair our ability to breathe, limit visibility, and alter the plant growth on Earth. Leaching happens when excess water, through rainfall or irrigation, takes water-soluble nutrients out of the soil. When water carries these nutrients away, they need to go somewhere. Factors that need to be taken into account to prevent excessive nutrient loss includes soil structure, crop planting, type and application rates of fertilizers, and a few other factors. Algae and other plants use nitrates as a source of food. If algae have an unlimited source of nitrates, their growth becomes unchecked. During eutrophication, there is first a release of organic materials into the water bodies. Due to an increase in the organic materials, there's a rapid growth of algae and other plants takes place. With the algal bloom, the sunlight is blocked and most of the plant starts dying. They start rotting, and then the decomposers acting on the rotting algae take up all the oxygen. The animals inhabiting the water bodies then start dying out because they don't have oxygen. Learn more about the macro and micronutrients under the biological section, or visit my TPT store for worksheets and practical projects based on eutrophication.